Alright, right now we're doing 6.1. Chord central angle conjecture. C54. Alright, here we have our circle. Okay, here we have two chords. Okay. Now, if these two chords are congruent, that means you draw a line and create a central angle. That means these angles are congruent. That's all that means. Now C55. Chord arcs. Alright, here we have another circle. Here's the center of it. Here we have a chord. One here, and another one here. And they're congruent. Alright, the first one, C54, told us that if we drew an angle connecting these two chords to the center, those angles are congruent. Now, C55, chord arcs. If these two chords are congruent, that means this arc here and this arc here are congruent. So, if we have two chords that are congruent, we have a central angle that's congruent, and those two arcs are congruent. Okay, now C56. Perpendicular to a chord. Alright, here we have another circle. There's the center of it. Now, if we drew a line from the center of the circle to the center of that chord, this is going to be a 90-degree angle. So all C56 is telling us, we have a chord. We draw a line from the center of the circle to the center of the chord. That creates a 90-degree angle. That's all C56 means. Now, C57. We have another circle, and here we have a center. We have two congruent chords. Alright. C54 said if we drew two angles connecting these chords to the center, that's central angles. These two central angles would be congruent. Our next one, C55, two chords. If these two chords are congruent, that means these outside arcs are congruent. Now, chord distance. If these two chords are congruent, that means the space between this center and this chord, and the center of the circle on this side to this chord, these are congruent. So if this is 7, this has to be 7. If these two chords are congruent, the space between them, if this one was 8, this one would have to be 8. C58. All right. C56 said, if we drew from the center here to the center of the chord, it'd be perpendicular. This is just the opposite, or the converse. If we had bisected this chord in half with a perpendicular bisector, it would automatically, well, I said again, this chord, if we cut it in half with a perpendicular bisector, it would go through the center of the circle. If we had a perpendicular bisector, it would go through the center of the circle. Now, if we had these are 2, 56 and 58 are just the opposite of each other. If we went from the 56, we went from the center of the circle to the center of this would be a perpendicular bisector. If we went from this chord and created a perpendicular bisector of this chord, it would go directly through the center of the circle. Alright, let's try some of this out. Okay, we have a circle. Alright, we have a circle. Now, we need to find what x is. These two chords are congruent. If those two chords are congruent, that means chord arcs. Oh, 55. C55. If these two chords are congruent, that means these two arcs are congruent. If they're this is 128, that means this has to be 128 degrees. So now to find x, take your handy dandy calculator. 360, because it's a whole circle, 360 minus 128 minus 128. 20, 84. So x is 84 degrees. Okay? We have another circle. Here we have another. We need one more thing first. Those are supposed to be congruent. All right. So now we have a circle, 360 degrees. We have 3 chords that are congruent. If C55 chord arcs, if these are congruent, that means these arcs are congruent. So this equals y, and this also equals y. So all we have to do is subtract 372 from 360. 360 minus 72 and divide it by 360 minus 72 divided by 360. Alright, that's where I made my mistake. 360 minus 72 divided by 3, 96. That looks better. So now, this equals 96, this equals 96, and this equals 96. Alright, let's do one. Erase that first. Here we have another circle. Here's the center. Alright. What are we looking for? Arc AC. Okay. MC. AC. All right. Arc AC. What's arc AC? In chapter 1, if the central on any central angle, the arc of that central angle is going to be exactly the same. So if this is 68, this has to be 68. Okay. So now we're going to find angle B. So these are the radiuses. That means what? This is congruent, this is congruent, and that's congruent. No matter what, because this is the radius. All radiuses are the same in a circle. Okay. Now, if this is 68, this line is 180 degrees. So we go 180 minus 68, enter, is 112. So this is 112 degrees. So now, if that's 112 degrees, we have an isosceles triangle. What does that mean? isosceles triangle conjecture, those two angles are congruent. And inside a triangle equals what? 180 degrees. So we take 180 minus 112 equals 68. So now we have two angles that have to equal 68. So we divide by 2. So now we divide those by 2, 34 degrees, 34 degrees. So that's 34 degrees. So if this is 112, what does that have to be? 112. What if I drew a line from here and do another line to here, and I made this chord congruent to this chord? So, chord conjecture. If these two chords are the same, though, it means what? The central, the arc has to be the same. And then, if I do another line from here to here, since same thing as the central angle, that means if this arc is 60, this has to be 60. Also, conjecture, chord central angle conjecture. If this chord's the same, that means the central angle has to be the same. Okay? And that's 6.1.